Okay, this is section 8.5 chi-square test for the variance and or standard deviation. So test variances and standard deviation. We're using the chi-square test. So we use the chi-square distribution to construct the confidence intervals for the single variance or standard deviation. So now we will use the distribution to test the claim about the single variance and standard deviation. So characteristic of the chi-square distribution. So number one, all chi-square values are greater than or equal to 0. Chi-square distribution is family of the curve based on the degree of freedom. And the area under each chi-square distribution is equal to 1. And the chi-square distribution positively skewed, which is a right skewed. We found that the area under the chi-square distribution using the table G, appendix A, which is I provided to you already, for the right tail, left tail, and then two tail hypothesis. So table G give area to the right of the critical value, and for the right tail test, use area under the significant level alpha for the specific degree of the freedom. And then for the left tail test, subtract 1 minus alpha and use the area in the table for the value for the specific degree of freedom. For the two tail, divide by alpha by 2, use the area under the value for the specific degree of the freedom for the right critical value and area for 1 minus alpha over 2 for the degree of freedom for the left critical value. All right, let's look at this is a table for the chi-square. Okay, so we'll go back to the use them. All right, so example 1. So critical values for the chi-square distribution. So find the critical value for the chi-square. So right tail test with a degree of with a 15 degree of freedom, and then the alpha equal to 0.025. So in order to find the critical value, which is let's go to the degree of freedom was 15. Okay, and then the alpha equal to 0.025, which is right here, right? So your number C is 27.488. So that's a critical value. So 27.488. Number 2, left tail test with a 27 degree of freedom. And then alpha equal to 0.05, but with a whip tail, we have to find the 1 minus alpha, which is 1 minus 0.05, which is 0.95, which is, this is what I use. So go to the, oh, sorry about that, 8.5. Okay, so go to the table. So this time, we are using the degree of the freedom as 27, which is right here. And then go looking for the 0.95. So 0.95. Is it here? Okay. All right, 0.5 now right here. So your score is 16.151. So the critical value is 16.151. Two-tail test. So with a 9 degree of freedom, alpha equal to 0.01. So we need alpha over 2 this time. So 0.01 over 2, which is 0.005. And then another 1 minus alpha over 2, which is 1 minus 0.005, which is 0.995. Okay, so we're using these two the alpha over 2. Okay, so what I'm doing here, okay, and then go to previous page. Okay, so here the degree of freedom is 9. And then I'm looking for the 0.995, which is this one. So there's one already. And then 0.005, oh, right here. Okay, so this number, right? Yep. Which is, I'm looking at this number and then this number. All right, so your critical value is this time is 1.735 and also 23.589. This is what we use to compare. All right, let's do the problem. Let's do the actually more formula. Sorry about that. Formula for the chi-square test statistic for the single variance, and this is the formula. So chi-square is n minus 1 times s square over sigma square. So you understand what is the meaning of each symbol, right? So assumption for the chi-square test for the single variance, sample must be random selected from the population. Population must be normally distributed under study, and then observation must be independent for each other, okay? All right, let's look at the IQ test. Okay, a psychologist wishes to see if the variance in IQ of the 10 of her counseling patient is less than the variance of the population, which is a 225. The variance of the IQs of her 10 patients was 206 and tests her claim at alpha equal to 0.05, okay? So the null hypothesis is variance is 225, and the alternate hypothesis is the variance is less than 225, which is a claim. This is right here. All right, the critical value at alpha equal to 0.05, but this is a left tail test, which is I need to find the 1 minus alpha, which is 1 minus 0.05, which is 0.95. So I'm using this with a degree of freedom, which is 9, because of 10 patient. So with this 2, I need to find the critical values, okay? So use the table that we have here. So degree of freedom of the 9. Okay, and then the 0.95, which is right here. And then which is right here, okay? So I need to find the intersections. So I see as 3.325. So critical value is 3.325, okay? So which means on the normal curve, you have a 3.325, and then the left tail. So this is a critical regions. All right, we need to find the test statistic, which is chi-square equal to the n minus 1 times s square over sigma square. So n is 10 subtract 1. Of s square is 206, of sigma square is 225, comma is 8.24. So if I plug it in, it's right here. 8.24 less than 3. Oh, sorry, what am I talking about? I don't know which number is bigger. Sorry about that. Okay. So that's not true, right? Okay. Sorry about that. So 8.24 should be here. Sorry about that. It's greater than 3.25, right? So I know it's 33 something. All right, so now what I do is we do not reject the null hypothesis. Conclusion is there is not enough evidence to support the claim that the variance of her 10 patients is less than 225. All right, let's look at the next questions. All right. The next question is about outpatient surgery. So hospital administrator believes that the standard deviation of number of the people using outpatient surgery per day is greater than 8. A random sample of the 15 days is selected. Data are shown at the alpha equal to 0.10. Is there enough evidence to support the administrator's claim? Assume the variable is normally distributed. So this time, since we have a sample, so we need to find the standard deviation, which is going to be the sample. 11.2. Use the formula too, okay? And then h of 0, sigma is going to be 8 this time because they're using the standard deviation, okay? And the h of 1 is sigma is greater than 8, which is that's a claim. All right, so we need to have a critical value at the alpha equal to 0.10, and then it's a right tail. So n equal to 15, which means degree of freedom should be equal to 14. To find the critical values, gonna be using the table we have. So with the degree of freedom of the 14, which is right here, and then we have 0.10, which is this one. And the intersection that I see is going to be this one, right? So the number is 21.064. So critical value is a 21.064. So which means in the normal curve, right tail, so 21.064 is right here. Now you need to find the test statistic, which is chi-square equal to the n minus 1 times s squared sigma squared, right? So you got 15 minus 1 times s squared is 11.2 square. Sigma is given as a squared, which is 64, come out as 27.44. So 27.44, whoa, more than that, right? So 27.44, so which means the null hypothesis, because test statistic falls in the critical region. So that means there is enough evidence to support the claim that the standard deviation is greater than 8. All right, let's look at another example. Okay, all right, next problem. Nicotine contents of the cigarette. A cigarette manufacturer wished to test the claim that the variance of the nicotine contents of its cigarette is 0.644. Nicotine content is measured in milligrams and assumed that is normally distributed. A random sample of the 20 cigarettes has a standard deviation of 1.00 milligram and alpha equal to 0.05. Is there enough evidence to reject the manufacturer claim? So yeah, space not big enough, so let's try my best. Okay, so h of 0 is variance in here that we are using here, right? So it is a 0.644, and the null hypothesis is going to be different. So variance is not the same as 0.644. So the alpha is 0.05 with a 2 tail, which is we need to find the alpha over 2 as 0.05 over 2, which is 0.025 to keep it. And then 1 minus alpha over 2, which is 0.975. Okay, so we need to keep these two numbers with the degree of freedom, which is the degree of freedom, which is the 19. Okay, so use those to find the critical values. Critical values will be, okay, so degree of freedom is 19. So 19 is here with a 0.25, 0.025 and 0.975 right here. So as a number that you found it, so we found this number and also this number. Okay, so two number that I found it is this number and this number. Okay, all right. So critical value will be 32.852 and also has a 8.907. Okay, so if you use a normal curve, so one is 8.907, which is here, and then 32.852, which is this one is a critical region right now. So now test statistic, which is a chi-square equal to n minus 1, which is 20 minus 1, and s square, which is 1 square, over sigma square is already 0.644. Common is 29.5. So 29.5 is, not falls in, 29.5, isn't it? So we do not reject the null hypothesis, which means there is not enough evidence to reject the manufacturer claim that the variance of the nicotine contents of the cigarette is equal to the 0.644. Okay, all right. So this is a step where so you need to say there is not enough evidence to reject the claim, which is variance of the nicotine content of the cigarette is equal to 0.644. Okay. All right, let's use a p-value, which is I'm not really recommend to use a p-value here, but we still need to try. Okay. So the right tail n equal to 9, chi-square is 19.274. So we need to find the degree of freedom, which is n minus 1, which is 8. And then we need to find the 19.274 is in between where? Okay, so use the table we have. So from the degree of freedom of the 8. Okay, and then I'm looking for the number that close to the 19.274, which is that number is between this number to this number. So I need to keep it of this two of the alpha. Okay. All right. So that number is in between the 20.095 and then the 17.535. So if I say the 19.274 as a p-value as compared to the alpha, it's going to be 0.025 and 0.01. And then we're going to compare with the alpha. The left tail degree of freedom is 22. So now we have to find the 1 minus alpha, which is with a. So you just need to find the alpha with the. Degree of freedom is 22. So 1 minus alpha that we found it. Okay, so let's get that out as alpha first, okay? So alpha that we found it. So with the degree of freedom of the 22, which is right here, and then the 3.8, whoa. Okay, so yeah, that number is less than this number, isn't it? Which is, this is what you need to keep this, is that's a kind of alpha. Oh, sorry about that. So, but we have to subtract it. So that's the smallest alpha we can find is 0.995, which is a 0.005, okay? And then the p-value, which is actually the less than the 0.005. Of course, greater than 0 though, okay? Two-tail. So degree of freedom is going to be 23 this time. And then you just need to find the 12.733 is in between which number with a degree of 23. Oh, what am I keep doing? So degree of freedom is the 23 right here. And I'm looking for two number that covers those. So I think what happened? And then I found these two numbers here. Okay. And then this is actually the what I found there, okay? All right, so what I do is in here, okay, go back. So it's in between the 13.091, which is 11.689, but we have to actually the 1 minus 0.95 to get the p-value. But this time is actually when you subtract from the 1, the other side must be greater. And then it becomes 0.05, which is a p-value, 0.025, right? And then we need to make a doubles. That's what the p-value do with a two-tail. And 2 times 0.025. And then it becomes 0.10 as a p-values. And then you need to compare with the alpha to decide it's a rejected or not rejected, okay? All right, let's do the last example. So car inspection times. A researcher knows from the past study that the standard deviation of the time it takes to inspect a car is 16.8 minutes. A random sample of the 24 car is selected and inspected. The standard deviation is 12.5 minutes. At the alpha equal to 0.05, can it be concluded that the standard deviation has changed? I'll use a p-value method to assume the variable is normally distributed. Okay, so h of 0, which is standard deviation is 16.8, and also standard deviation at h of 1 is not equal to 16.8. All right, so now we have to put the test statistic, which here is chi-square, which is n minus 1 s square over sigma square, which is 12.733. So I need you to find the degree of freedom, which is 23. All right, so now 12.733, which is a two-tail, right? So this is a two-tail. So I need to find the distinct numbers between the 13.091, which is 11.689, which is 0.95, match that number as a p-value. But as a p-value, we have to subtract it from 1 minus of each of the alpha we have from the table, which give us 0.05 p-value, which is 0.025. Now we need to make a doubles of that. And then I got 0.10 p-value and 0.05. Now we need to compare with the p-value, which is this is the p-value range. Is it the less than alpha, which is a 0.05, which is smallest we can get is 0.05, right? So no, it's not, isn't it? Yeah, it could be the greater than 0.05, right? So we do not reject the null hypothesis. Sorry. Which means there's not enough evidence to support the claim. All right. Thank you for listening.